Hello and welcome to today's lesson. Many people define maths in various forms and some even just relate it as the science of numbers. But then, maths is just more than dealing with numbers. When we're looking at maths, we are looking at the science of patterns. From a very early age, children are exposed to all manner of patterns with regards to colors, shapes, spiral arrangements of leaves, flowers, and tree trunks, and many things around them. So from an early age, children are so exposed to patterns. Now, and that is the beginning of mathematics. However, in their developmental stages, as they begin to grow, the children become more socialized by school and the environment to see maths as just a rigorous or rigid system of getting to have formulas and some strategies or algorithms to come up with solutions, and it makes it very abstract in their minds. So, and in these principles, they just see it governed with speed work and then some form of being able to memorize things. However, we need to reinform our minds and the minds of children to see mathematics as an ability to recognize and interpret patterns and see the interconnections that they present. And I believe that to grow mathematically, we must expose the minds of young children to a rich variety of patterns and some of these interconnections around them. When they get exposed to this, it makes them to see the beauty of mathematics. So in this series of videos I'll be presenting to you some interesting number patterns that would make maths to be more fun and attractive. Today we would want to see one interesting thing that would have to do with odd numbers. So today we'll look at one interesting phenomenon that shows that perfect squares are actually a sum of odd numbers. So perfect squares are sum of odd numbers. This is a beautiful math pattern. So for example, if I have the square of 2 squared is equal to 4. But then this also tells me that using the principle of perfect sum of odd numbers, the first two odd numbers, the sum of the first two odd numbers is going to give me the perfect square of, or the square of 2. So that would be 1 plus 3. 1 plus 3 also gives me 4. Now let's try for 3. So 3 squared, of course, 3 squared of course is 9, which is equal to 1 plus 3 plus 5. The next is 4. 4 squared is 16. And that will be the sum of the first 4 odd numbers. So basically that will be 1 plus 3 plus 5 plus 7. Interesting. Now the next one is 5 squared. That of course is 25, equal to the sum of the first 5 odd numbers. So that will be 1 plus 3 plus 5 plus 7 plus 9. Alright, so you want to pause the video and then try for many other perfect squares from 6, 7 and all that. You see a very beautiful pattern. But why is this pattern the way it is? So let's try and use a little geometry to show it. Now let's see, we have this 1 squared. If I add 3 other squares to this, let's see this way. 1, 2, 3. So 1 squared, so let's begin. 1 squared is equal to 1, just 1, equal to just 1. Equal to just 1. But when I add 3, I also get another square, which is 4. Now let's add another square to this. 5. So 1, 2, 3, 4, 5. So I get another squared as well. So let's add. So 3 times 3 gives me 1 plus 3 plus 5 also gives me 9. So let's see for 4, another 1, 2, 3, 4, 5, 6, 7. And I'm getting 16. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16. So I have 4, 4, 16. Now, let's see for 5. I'm going to add another shape to give me that square. So it goes this way. 1, 2, 3, 4, 5, 6, 7, 8, 9. So I now have 5 groups of 5, 25. So the more I add, the odd numbers are going to be what's going to fill this size like this. And the more I go, the more I get perfect squares. So we'll have something like this. Let me just make it. Yeah. So for 25, this will be 1 plus 3 plus 5 plus 7 plus 9. Gives me 25. So this is a very beautiful pattern, and see you in our next lesson as we observe some other patterns. Have a nice day. Bye.